Hi everyone, my name's Yifan and I'm a PhD student at UC Berkeley. Today I'll be talking to you about B2, bridging code and interactive visualizations in computational notebooks. This work is done with Joe at Berkeley and Arvind at MIT. Many data scientists use the notebook to explore data. They could manipulate the data with code, they could visualize the data, and they could write down their thoughts. Professor Press calls this literate computing after Knuth literate programming, where the analyst is able to weave the narrative along with a live computation environment. However, this experience could become a little lacking as I explore the data further. So here I have analysis of wildfires in the United States, and I have created a visualization of the distribution of causes of fires. And as a next step, I visualize the distribution of fires by the state. And I noticed that Georgia has a surprisingly high count, and I want to filter the cause distribution by Georgia. Currently, the only way I can do this is to write out code that says fires state equals to Georgia, and I have to either create a new visualization or to replace the old code and execute the cell. This could be a little bit slow, especially compared to another commonly used data analytics tool, interactive data visualizations. This work is an exploration to bridge together the two mediums, and it's not as simple as just programming an interactive visualization into a notebook cell. We identified three gaps. The first is a layout gap. We can see here that the notebook is linear, where visualizations and code are interleaved, whereas in interactive visualizations, the visualization are a lot more compact. This is really important for coordinated views. If the visualizations don't even fit into one screen, then how is it possible for the user to be able to interact with visualizations? Second is a semantic gap. If we look at the notebook to the left, we have already done a lot of work in terms of specifying the static visualizations via querying and the visual encodings. However, to create the interactive visualization creates a lot more work. And if we just look at the queries, it's actually not that hard for us to infer what the notebook user may want when they click on GA and how they want to filter the cause distribution. They want to see all the causes in GA. And so there's a missing opportunity here where the interactive visualizations need to be re-specified despite the fact that the provenance information has been provided in the queries. Another issue we see is that the interactions are siloed in the visual format and inaccessible for further analysis in code. So here, as the user painstakingly specifies the interactions and interacts with the visualization, the data and the code that derives these filter results are all siloed and inaccessible in code. The third and the last gap is a temporal gap. A notebook is persistent. All cell executions are recorded by default, and this is great for reproducibility. However, on the other hand, interactions are by nature transient, and the plus is that we can explore a lot of different options without creating clutter. To bridge these two mediums, we really have to create a mechanism to accommodate for both modalities so that the notebook user could make the best use of both worlds. We believe that we made a good attempt at bridging these gaps in B2, and I'm going to show you a demo. To start the demo, I'm going to import B2 from the library and create an instance. Once B2 is created, it augments the traditional notebook view with a dashboard-like area and some additional buttons. So we're going to get started by looking at some data from wildfires in the United States taken from Kaggle. The data frame returned by B2 is the same as any data frames you would expect from libraries. You can inspect it, you can apply operators on them. But what's more interesting is that B2 here is aware of this data frame, and it actually augments the pane to the right with the columns of this data frame. B2 makes it super easy to look at distributions of variables. You can just simply click on the value you're interested in. So for instance, here I'm interested in the distribution of causes, and you immediately see a distribution of these causes. And what's special is that B2 does this in a transparent manner that's not locked into the UI side. You actually get to see the code that was used to create this visualization, which means that I can actually also create visualization of my own. So for instance, here I might be interested in looking at a scatter plot of the size and the discovery. So I can go ahead and execute this query, and a scatter plot would show up. And we can make the interesting observation that the large fires tend to happen around noontime, which makes sense. We can also continue to interact with B2 via the shelves. And what's even more interesting is that B2 actually makes these static visualizations interactive by automatically analyzing the queries. So here, if I'm interested in how lightning fires has changed over the years, we can just simply click on lightning and see the values change. We can observe here that 1994 had a slightly higher than average causes by lightning than the years around it. We can also make the interesting observation that a large proportion of these large fires were actually caused by lightning as well. Another interesting thing that B2 does with these transient interactions is that it reifies them into code format. So here we can see that B2 recorded, oh, we made the selection of lightning. We can continue making interactions, and as we make these interactions, B2 will continue to record the selections we've made, but in order to conserve space, it actually folds them so that it doesn't bloat up. But when we want to revisit past interactions, we can go ahead and unfold it and uncomment any previous state that we want to go back to. So for instance, right now, campfire is selected, but if I uncomment arson and execute the cell, you will see that arson is now selected. And if we find the current state of the visualization interesting, we can actually also take a snapshot of them so that they are persisted into the notebook view. That way, even when I hide B2, the cells are still persisted. As we can see also, that there are cells with emoji colors annotated. This is our way of helping the developer make sense of what cells are generated by B2 and for what purposes. So the yellow ones here indicate that they're for creating visualizations, and the blue ones are the interactions, and the orange ones are snapshots of charts. Another example I will show you is the ability to look at the visualization result from the code side. So to cross the bridge from the visual to the code. So I'm very interested in what is happening with this scatter plot here of this outlier values. I went ahead and brushed this region, and as we can see, not much is showing up. Let me get rid of the background data. And so here we see that most of these big fires are caused by lightning, with some being miscellaneous and equipment use. So if I do fires.get filtered data, I can actually just look at this selection result right here. We can actually even make this interactive by marking this as reactive. So what happens now is that if we do brush a different area, this cell will automatically execute. And so we've created us this super handy little tool. This way, we're able to bring the transience of interactivity into the persistence of the notebook by connecting the two states via this API. We can actually do something even more interesting with this setup. So instead of just seeing the data in a table format, I can maybe do a visualization that's difficult to do right now with B2 in the dashboard. So I'm going to copy paste some data I've prepared for plotting the visualizations. So without reactive, we'll be able to do a visualization of all of the fires in the United States. But it might be handy to, for instance, be able to visualize these heat maps based on my selections. And so we can bring back the reactive as well as the get filtered data. And then if we re-execute the cell, we're able to see that, oh, like these big fires I just selected happened in Washington and somewhere in Alaska. So let us just remove this chart and do some other exploration. So if I click on lightning, I can see that it's skewed towards the West Coast, at least with the sample data I have here. And arson seems to be more skewed to the East Coast. Now, when we look at our notebook, maybe after some pauses, some of you might notice there's a lot of interaction cells. We can actually easily overcome this clutter by toggling them. Then the rest of the notebook seems a lot simpler. However, we can always bring them back if we do need to get a sense of the provenance. It's like, what did I explore? How did I get here? And share this with others as a more complete narrative. Lastly, I want to show that not only could you access the current selection via API call, you can actually directly access the code as well. So here, if we want to access the computation of the year distribution based on the debris burning values, we can actually copy code to clipboard. And if we create a new cell, we're going to be able to paste that code in and execute this code and also access this value. So this way, if you want to share the result with someone without giving them the whole notebook, you can just copy paste this query result over. Hopefully by now you're convinced that we've overcome the bulk of these gaps and are able to help the analyst smoothly transition between coding and interactions. To evaluate how B2 facilitate data exploration in the notebook context, we conducted a user study with 7 participants, all with some experiences with data science, either through coursework or their professional jobs. We started with a 20-minute tutorial, followed by 2 specific tasks and 1 open-ended data exploration on the Berkeley Police call for service data. To give you a sense of how the users engage with B2, here is a visualization of their actions. The x-axis represents time and the y-axis represents the different participants. Each tick represents an action the user has taken either on the notebook or on B2. You can see that the darker blue indicates user interactions with the visualizations in the dashboard pane. So here we can see that the users engaged extensively with these interactions, and they did so in a way that was interweaved with coding. Some users said that B2 spares the user of tedious commands and really facilitates the EDA process. Others commented that the kind of interactive visualization facilitated by B2 is difficult to do with standard libraries. Another pattern that we've noticed is that users really engage with B2 to cross the bridge, so to speak, between the coding land and the interaction land. Some of them commented that it's often the case that their colleagues wanted to not only see the visualizations, but the underlying data and even code, and B2 made that really easy for them. And another commented that the ability for B2 to reify their interactions into a persistent form was super helpful for them to remember what was going on if they left their task for a while, for instance, for a coffee break or a lunch break. Participants also pointed us towards interesting new directions. One of them suggested that B2 could be really useful for people who are just starting out with programming and aren't as familiar with all the libraries and tools. Of course, there's also room for improvement. Some of the users still found the reified interactions to clutter up their notebook, so clearly there's still some design space that's worth exploring to deal with the trade-off between reproducibility and literate programming, as well as this ability to explore without creating clutter. Overall, the participants found B2 to be quite useful. And that concludes a quick tour of B2. Thank you for your time, and please refer to the paper for more details.